Hi, this is Gary Baker, K7 EMF. We're going to model a true ladder line dipole, a 160-10, using 600 ohm true ladder line and a balanced antenna tuning unit. So we're going to start with EzNec version 6.0, and the first thing we want to set up is our antenna. So we'll go to wires. And we'll take a look at our antenna, and for this antenna it needs to be 240 feet long. It's going to be an inverted V. So one of the end wires, two wires, to be comprised of two wires and center fed. So one coordinate of the outside end of one of the wires would be 0 and 0 with a 20-foot elevation. The other end's 120 feet long with a 55-foot elevation at the apex. The second wire starts at 120 with a 55 apex and goes out to 240 feet for a total length of 240 feet. So then, to be sure we have this set up right, let's take a look at our antenna, and we can see that our antenna is definitely looking symmetrical, so we should be good to go. The next thing we'll do is run an SWR sweep, which will, I'll go ahead and start it running. This will output for us a file from EzNec that will indicate the feed point impedance of the antenna from 1.8 to 29 megahertz, and it'll also show the SWR for this 600 ohm ladder line. And then once we get this file, then we will switch over to SimSmith, and we will model the entire system using the antenna feed point impedance as the source of our data. Okay, so there is with 600 ohm feed line. This gives us an idea of what our SWR is, and you see it's 10 to 1 or less out at this point right here, which is about 5.9 megahertz. So just to be sure that we have the right file, we'll move this back to 1.8 megahertz, and we can see our feed point impedance is 12.66 with a minus J 96.29 ohms. So now we will execute SimSmith, and SimSmith is asking us to reload this file right here, lastz.txt, which was generated from the SWR plot that we just did. So we'll reload that. Now, if we look on our Smith chart, this is the the end of the feed line impedance looking into the ATU, so that would be at this point right here. This is our ATU itself, that's the capacitor. We can move on either side of the roller inductors, and this is what the roller inductor network looks like. So the object is to get this impedance right here, which is presented to the feed line. We need to get that to the 50 ohm non-reactive point. Remember, this in this direction from the horizontal line across the Smith chart is inductive reactance. This is capacitive reactance. Over on this side would be higher resistance. This side would be less than 50 ohms resistance as it goes this way. So let's take our and we'll increase our inductor size and see how the Smith chart reacts, and you can see that impedance is coming in, but it's too low. So we need to get this point out to 50 ohms. So now we'll increase our capacity, and you can see that that's still, we can see what the pattern is, and we can't get it far enough out. So let's decrease. Okay, that's not going to get it for us either. Well, I forgot to mention that we've set up 1.8 megahertz for our generator, 1.8 megahertz for our feed line, and we can see that we have the proper impedance from the file. So let's change the mode. Let's switch it over this way and see how this reacts. And we're still not able to bring it in, so let me switch it back over the other way. Okay, now we're getting somewhere. Okay, we'll adjust our inductance and our capacitance. So it looks like we're getting a little closer. And getting a little closer yet. By the way, I'm using the raise and lower arrows, the page up and page down, in order to modify these values. So I just click on them. Okay, there we have a 1.035 to 1 SWR, which is quite acceptable, even though with the real thing we can get numbers down in the 70 to 80 dB return loss, which is a phenomenal number. Okay, so we're running 100 watts at 1.8 megahertz. Our losses in the two inductors is 898 microwatts. The losses in our capacitor is 1.2 watts. The loss in our feed line is almost 11 watts. And the power to the antenna is 87.76 watts. That could be translated directly into percentage, which is 87% efficient. So we can see that the ATU is extremely efficient at about 98.8%. So we have a very efficient antenna and feed system designed, which should work out quite nicely. Thank you very much. This is Gary, K7EMF, saying 7 3s.